Kia ora team, welcome to an online tutorial on Level 3 Physics Mechanical Systems banked tracks. Now today specifically we're going to be looking at the 2016 NCEA question 1, A and B, which focus on banked tracks. We're going to be looking at free body diagrams, how to draw a free body diagram for a banked track question, as well as how to use that diagram to calculate the net force, or in this case the centripetal force. Cool, so in the question, this very well drawn Alice is in a car on a ride at a theme park. The car travels along a circular track that is banked as shown in the diagram. So for A, our question A, they want us to, on the diagram, draw labelled vectors showing the two figures acting on the two forces acting on the car. You may assume that friction is negligible. Okay. So first of all, thinking about we're on Earth, or you assume so, what force is going to be constant on us? The force of gravity acting on the mass of the car. So we're going to draw on our weight force or force of gravity. Okay. Now, please ignore my rather unconventional straight edge. I left my rulers at school. Okay. I'm going to start off by drawing on my weight force, Fw. Okay. Now, I'm going to just draw something on here to help out. I'm going to draw a little normal on, going in the opposite direction. Now, looking at our diagram, we can see that the car is on an incline. Therefore, the support force given by the actual inclined track or road is not going to be acting in the same direction or opposite to our weight force. It's going to be inclined as well. And using our understanding of geometry and parallel lines, we know that if we draw a normal here and intersecting that, we are also going to get a line that's going to be in a similar incline to that of, or the same incline as that of our tracked road. So drawing our weight force on, we're going to have the same incline as the road, and we get the support force offered by said track or road. Okay, and I'll make a mark that this here is going to be 20 degrees. Okay, so that's A, that's done. This is, believe it or not, a merit question. So if you drew either of these on, our force due to weight or gravity, and you can give it either of those, Fw or Fg, and our support force or our normal force, accept both. You get both of those, you get merit. If you got just one, you get achieved. So a really easy question there. Okay. Now for part B, okay, the mass of the car and the passengers, and I'm going to write this down, M equals 9.60 times 10 to the 2 kilograms. Okay, that's their mass. The track is banked again at the same angle, so we're using the information from here, 20 degrees. Use a vector diagram to calculate the size of the centripetal force on the banked car, or on the car driving around the banked track. So we are going to just use the information that we've taken in our previous question. So all that we've got here, we're going to track across. Okay, we're going to remove the car, we're going to remove the track, and we're just going to think about what forces are actually at play on the car. Okay, so if I draw those, I'm going to have my weight force. Oh, Fw. Okay, now I've got my support force. Now it's at an incline. So there's actually two ways you can answer this type of question. I like to complete the triangle. You can actually draw it up here and then infer that this line here would be the same length as your weight force and draw your resulting force that way, but I'm going to do it this way. Okay, I'm going to take that, I'll get my angle. Okay, I'm going to draw on, remembering the direction and orientation of our vectors, doesn't change. Okay, and I screwed up a little bit, but that's alright. I'll draw my force support. Okay. Now, here is my vector diagram. I have to draw on my resulting force, or my net force, okay, which is going to be, in this case, our centripetal force, coming across to the left. This here is F net, okay, which for us is going to be our centripetal force, Fc. Now, we have a known value for our mass, okay, so we can actually calculate the force of weight acting on this object. So this is going to be mg. G for us being 9.81. Okay, so we can actually calculate, we have a known value for Fw, right? We can use our understanding of trigonometry and knowing that this angle here, our understanding of geometry, is going to be additionally 20 degrees to actually calculate what our force net will be. Okay, so if, like me, you forget which ones we should be using, I always write out SOHCAHTOA. Okay. Now, additionally, if you're still struggling with trigonometry, a really easy way to get through this is just to label it. I always start it out with my opposite. Here's my angle. This is going to be my opposite. This is going to be my adjacent, and this is going to be my hypotenuse. Okay. I can see that I have my adjacent. I have this value here, or I can get that value, mg. Okay. And I want the opposite, so I see that I'm going to use tan. Okay. So I'm going to rewrite these equations. So I'm going to say tan angle. Okay. Tan theta, or tan 20 degrees, okay, is going to equal my opposite, Fc, over my adjacent, which is mass times gravity, which is this number here times 9.81. Okay, so now if I'm going to put it all out into working, okay, I can rearrange this here, this equation, and I'll just knock that off, so we're getting rid of all that. Okay, I can rearrange this equation to make Fc the subject to get Fc equals 960, okay, mass of the vehicle times gravity 9.81, okay, times tan 20. Now, if I solve that, I get Fc equals 430. Okay, my answer here is not complete. I need to give my unit. Remember, we're dealing in forces, so I'm going to have newtons. So, pretty simple one to start us off. We looked at mechanical systems, bank tracks. We've looked at free body diagrams using our understanding of geometry, essentially to draw a free body diagram. And then we've used that understanding of geometry and our free body diagram to then infer and calculate our force centripetal for a car driving around a bank track. Hopefully this is helpful to you. I would recommend going and giving this question a shot, checking your answers, maybe using this tutorial as a guide. All the best.